Yellowstone Volcano, how U.S. Geological Survey finds not normal signs of movement to identify hazards at the supervolcano. Yellowstone volcano geologists monitoring the U.S. supervolcano for signs of activity keep a watchful eye on any unusual ground deformation. There are events, Yellowstone, they say, is like heaving or breathing. It inflates, it deflates. And we saw that it's inflating in areas of northwest Wyoming towards Hebgen Lake. So they watch for the ground deformation, which could be an indicator of dangerous volcanic activity. The Yellowstone Volcano Observatory, YVO, and U.S. Geological Survey, USGS, are the first line of defense against a Yellowstone eruption. Well, they're not against it. There's nothing they could do to stop it, but they're watching for something. For decades, the geological agencies have tracked ground deformation and seismic activity within Yellowstone National Park. The ground movements is a sure indication of bubbling danger, often precedes the incoming eruption. In 1994, for instance, geologists noticed rapid ground motion at the Rabaul caldera in Papua New Guinea before the volcano erupted there. According to USGS, the ground deformation was so intense, a local reef rose from the sea fast enough to strand fish out in the open. A similar incident occurred in 1927 when Fernandina volcano in the Galapagos caused the coast to rise and trap a fishing boat above the water. Geologist Beth Bartel has now said this in the edition of USGS Caldera Chronicles, scientists monitoring Yellowstone for such signs of activity. She said at Yellowstone and other calderas, changes in deformation patterns from uplift to subsidence and back again are a common occurrence. But by studying these changes, we hope to learn more about the subsurface conditions that are causing ground to move and also to monitor for changes that are not normal. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. We'll take a look at the GPS of Yellowstone so you can see by yourself what is happening there as far as deformation is going on, the inflation. Now, recognizing the normal from the unusual, they say, is key for identifying the potential for future hazardous volcanic activity. Yellowstone's volcano's last caldera forming, the super eruption, went off an estimated 640,000 years ago, and it was powerful enough to cover most of the United States in ash. But the volcano has not been entirely dormant since, and the Earth is a constant state of flux as tectonic plates shift, grind, and pass over one another. Just a couple of days ago, we had a 6.1 earthquake shaking the whole of the mid-Atlantic, especially the Azores volcanic islands there. Now, of course, we also had the 6.1 in China today. We have a lot of big earthquakes worldwide, and we know the Earth is growing at the rate of a human fingernail every year. Now, ground movements in this area, in Yellowstone, is the principal reason why mountains and volcanoes in the world exist, causing colliding tectonic plates pushing the Earth upwards. When magma pools near these points of collision, volcanoes like Yellowstone are born, and the magma itself and the underground water system it heats up also contribute to movements of volcanic systems on the surface. Motion caused by the change in pressure within the volcano's plumbing system is known as deformation, and precise instruments and GPS stations positioned around Yellowstone trace this movement to get a better idea of what is happening below. And Bartel said sometimes motions are so large we can see them with our eyes. In the spring of 1980, a bulge in the north flank of Mount St. Helens volcano was growing by more than 3 feet, about 3 feet per day as magma pushed up into the mountain. 3 feet a day, you could imagine. While the exact magnitude of the motion was measured with precise ranging instruments, the growing bulge was clearly visible to the naked eye. and Mount St. Helens erupted May 18, 1980, beginning with the collapse of that bulge. The USGS primarily uses GPS tools, and we're going to take a look at the GPS of just a few seconds. They use GPS tools and interferometric synthetic aperture radar, INSAR for short, to measure the shift in ground levels. Up to now, the largest lift recorded at Yellowstone over the past few decades was only about 2 inches, that's about 5 centimeters per year, between the years 2005 and 2009. Miss Berth said that the largest uplift ever, by contrast, averaged about 25 inches per year between 1982 and 1984 at the Campiflegri caldera, the supervolcano of Europe, which is in Naples, Italy. And you'll see a couple of videos back at that one. We're calling that the very dangerous volcano that we shouldn't be worried about Yellowstone that much, but Campiflegri in Europe, which is inflating. Let's go to the GPS so we can see what's happening with the deformation in Yellowstone. And this was by Express UK, Sebastian Ketley. Let's take a look at the GPS now. Seismo Berkeley, and these are all the GPS stations worldwide. And here we are, California, Wyoming, and let's remember that there's a mantle plume originating from Baja California, which is in a Y shape. The western branch goes under San Andreas Fault in the Walker Lane Fault System, all the high-threat volcanoes of California west coast. And the eastern branch goes through Nevada, up through Utah, into Wyoming, and then branches to the west over under Montana and Idaho. Now let's go and take a look at, let's take a look at our GPS here. Wyoming, that's it. Idaho Falls. Let's go to our satellite. Okay, that we can see better that way. Okay, this is craters of the moon. You can see the lava flow right there. Beautiful, pristine lava flows. They're still there. Look at that. Let's go in a little bit more. Okay. Craters of the moon. Okay, look at the lava flows there. It's amazing. And here we are. Okay, that's Yellowstone Lake. You can see that over the caldera. This is the border of Wyoming. This Z shape there is Hebgen Lake. Hebgen Lake Estates. That Z shape is Hebgen Lake. And this is, the whole thing is the supervolcano caldera. Part of the southeast of the caldera has this Yellowstone Lake over it. And even the breeze giving it little waves over that water, that over on the lake, can cause earthquakes, from what geologists have told us. And the earthquakes, of course, we do have cracks in the Yellowstone region, and even the cracks from the surface down towards the innards of the 100 feet wide, 100 feet down, they could go towards the roof of the magma chamber and split the roof that way. And this is what the geologists tell us they are very wary about. Now, this here, let's go to the GPS here. Where are we? Let's take one around Yellowstone Lake, this one here, to see what deformation we have. Okay, this is the east-west. If it goes up, it means it's going east. This is the north-south. If it goes up, it means it's going north. So this is not going up, it's going down, which means it's going east. It's going east, it's going southeast. And this is the deformation, it's basically going down. That's that area there. Let's take one to the south of the lake. See the deformation there. Not very good, but it's going southeast again. And we know that most of our quake swarms take place in the northwestern part of Wyoming. Let's go here. And P714, again, it's going northeast. And this here we have inflation. This shows our inflation. And let's go towards Hebgen Lake. We'll see a lot more activity there. P458, and there you have inflation. It's going southwest, and it's inflating. As you can see, seasonal, but it's inflating. Since 2007, you can see it's up to now, it's inflating. That's Hebgen Lake area. Let's take this one here. Okay, it's going southwest, and again, it's inflating. Let's take one to the east of that area. Okay. Again, it's southwest, and that's not very good. That's not a very good graph. Let's take one near Montana. This one here, P457. And again, that's inflating. So all of this area is inflating. All of this area is inflating, as we just saw. Let's take this one here towards the border. It's going southwest, and this is all over the place. Inflating, deflating, inflating. Basically, it's heaving over here. Let's take this one here, P720. Not very, it's going southwest, but basically deflating, now inflating. And take this one here, Pilot Peak, 721. That's pretty steady. Okay, so the northwest part here of the caldera is where we're having a lot of quake swarms, and this is where it's inflating here. So that's the deformation taking place there. Please leave your comments, and thank you for your support.